My name is Devat, and this video is about unsupervised learning, some agentic pattern decision making, and how to implement machine learning in real world business problem end to end. So first start with unsupervised learning. So we can let me give you one example. There is a uh, house, 2 BHK house at particular location, and its price is around it's X unit price at that house. Same likewise, I have data. I have features and I have price. I have features, I have price. So I can predict new label. I can predict new feature based on the previous data. That's what that's learning algorithm or algorithms category is known as supervised learning. Now, if I want to open one restaurant, let's say Domino's, I want to open a Domino's outlet. Now I don't have any prediction. I have to uh, survey where the people are like to eat pizza, where people are doing parties and going out for a weekend and love to eat outside, love to eat pizza. So those type of data I have, and I have to group some of those customer into a cluster, and based on density or cluster size, then I have to decide where this is the exact location start my I should start my Domino's outlet. That's that is known as unsupervised learning. In unsupervised learning, I don't have any output data column, unlike supervised learning. What algorithms comes under this categories? K-means clustering, very famous algorithm and very basic. K-means is a linear regression for unsupervised learning. Yeah, it's a very basic algorithm based on common sense that it divides data point based on centroid of the cluster. Like each data points inside that particular centroid is likely same mentality or same category, similar to the same is true for the different cluster. Then another thing is DB scan, then principal component analysis, DCA. Then there is also hierarchical clustering, TA, TSNE as well. There are many algorithms for unsupervised learning, but universal truth about all those algorithms is follows as the supervised learning only. They have one hypothesis. It might not look like mathematical shape. Some algorithms look like shape, mathematical shape, some might not. So they have hypothesis, they have some shape, then they have loss function. Yeah. Although we are not predicting or classifying anything in unsupervised learning, but based on the cluster, based on decision what we are making, it should be to solve our business problem. If it is far away from the actual value, then it's a loss. It is considered as a loss. That's why we are putting loss function over here as well. And as we have loss, we have to optimize it. So there is the optimization uh, category as well. So same same way supervised learning has hypothesis, loss, and optimization. Unsupervised learning has the same categories: hypothesis, loss, and optimization. Yeah, moving to the third point now. So this was about unsupervised learning. Now let's talk about some design patterns. Well, let me give you one example. One company has deployed a machine learning model, and which is giving 91% probability that customer will churn. Very good. And customer did churn. But company didn't take any action. So point here is, without decision, without taking any actions, machine learning model deployment is totally useless. That 91% probability is not useful if marketing team or business team took any decision based on those machine learning output, right? I will give you another example. Let's say Jane Street is a large trading fund and hedge fund. Uh, if they are making trading decisions, quantitative tradings in milliseconds, seconds, they make trades, so much trades. Like, so for example, they want to, uh, let's say, want to make trades, okay, and want to predict that probability of is this trade is adverse or not. Means after I making trade, will I be on the positive side, means green side or a red side, right? So basically this is a problem. If Gen Street machine learning engineer only predict and deploy the machine learning model considering every aspect, features, and traders do not make any decision or action that the adverse probability, for example, adverse trade probability is, let's say, 55%. I should I should make trade. If the trader is not making any trade based on machine learning output, it's a useless, it's a missed opportunity, right? That's where five-layer architecture comes in. That's where five-layer architecture comes in. That's I hope that's I think some experienced machine learning engineer also don't know, or if even if they know, then I don't know. So let's dive into those five-layer architecture. Layer one is data. Obviously, there is no machine learning without data. So data. Continue into our example of Chain Street. They have petabytes of past data of stocks, execution latency, order books, uh, trade correlations, etc. Right? By using those data, they are they will build machine learning model, which is a second layer, which is prediction. They will predict based on business problem, but whatever trade we are making, that should not be a adverse trade, right? Rather than going aggressive buying every asset, we first check whether this trade will be adverse or not. If those trades are adverse, it will cost more than the profit, right? And because of there is a first they are losing money on the by being on the negative side as well. Plus they are losing money on the by paying fees of the trade execution to the stock exchanges, right? So that's the prediction. Prediction must be true. Prediction must be very good and aligned with the business problem. Third is decision. Third layer is decision. After I'm getting probability of 55%, that's 55% of chance that this trade will not be a adverse trade. The trader in the gen of the Gen Street should decide whether to take which decision. At 55% probability, should I go to the should I go to the aggressive to the market, or should I play on the easier side or the safer side, right? If probability is 90% that this trade is adverse, then I should do not I should don't do anything, right? Please don't do anything. Likewise, these are the decision. Next, after making decision, take actions. Take actions. That actions can be made by humans or made by AI agents or any other thing. Any sort of actions. Like after finding that this should not be an adverse trade, let's have a trade. That's the action, followed by a decision. And the final layer is feedback. What if my predicted output is this trade is adverse, but those that adverse trade is actually not adverse. So there I missed the opportunity, right? So again, there is a feedback loop. go to the data again, uh, tweak some data and training part, understand what is going wrong, whether I should bet on false negative or false positive based on uh, calculation of if what with calculation with one wrong trade cost me, let's say, around $10,000, and one right trade cost me profit me around 100K. Should I go with should I play safe or should I go aggressively? That's totally business decision, right? So yeah, these are the four layers, sorry, five layers, which is data, predictions, decision, action, and feedback. Yeah, so that's it for today. Thank you.